Hello, this is Tanya Chiu. I am a physicist and physics tutor at the same time. In this video, I am going to discuss one of the AS paper which was requested by one of the students here. The paper that I'm going to discuss is February-March 2024 paper 1-2 with the code of 9702. Let us get started. The first question, which row shows the physical quantity and its base unit in the SI system? So now you have to understand that there are altogether 6 base units. What are base units? Base units are the fundamental units which cannot be derived by any other units. So the base units, the 6 base units are ampere, kilogram, Kelvin, second, mole, as well as meter. 1, 2, 3, 4, 5, 6. All 6 base units which you are required to memorize. So let us look at the question here. Current, the unit is ampere, which is true. What about B? Force. Force is a physical quantity, but in terms of base unit, Newton is not a base unit. Newton is called derived unit. What about mass? Mass is a physical quantity, and the unit of mass is gram? No, gram is not base unit. Kilogram is the base unit. What about the temperature? Yes, temperature is a physical quantity, but degrees Celsius is not a base unit. Kelvin is the base unit of the temperature. Therefore, the answer is A. Question number 2, a car of mass 850 kilogram is traveling in a horizontal straight line. Diagram shows the 2 frictional forces acting on the car in opposite directions. One force has magnitude of 1,200 Newton and the other force has a magnitude of 1,600 Newton. Or what is the magnitude of the acceleration of the car? First of all, if you want to find the magnitude of the acceleration of the car and the forces are given, just use this equation. So I'm going to use F equals ma. But you have to bear in mind the F that I'm talking about here must be a resultant force. Since there are 2 forces acting on the car, you have to find the resultant force acting on the car. I would take the larger magnitude as positive direction because force is a vector quantity, direction counts. Since the 2 directional forces are in opposite direction, I would put positive for 1,600 Newton and negative to 1,200 Newton. So my resultant force would be 1,600 Newton plus, because result is the sum of all the forces that are acting on one object, plus negative 1,200 is equal to M represents the mass of the car, which is 850. A represents the acceleration. So 1,600 minus 1,200, that will give you 400 equals 850 A. A is equal to 400, divide 850. Your A should be 0.471 meter per second squared. Therefore, the answer is A. This is the solution. Now, the next one. An object of mass M is suspended by a spring from a fixed point. The spring has spring constant K. The object is set into vertical oscillation, that is up and down, and the period of oscillation is T. Which equation for T is homogeneous with respect to base units? Because they have already mentioned that this equation must be homogeneous, right? So what does it mean by homogeneous equation? In order for the equation to be homogeneous, all you need to do is just to test the left-hand side units, but the left-hand side unit must be in terms of base units compared to the right-hand side base units. If the left-hand side base units is equal to the right-hand side base units, then only you can say that the equation is homogeneous. Now, let me do it. T, let us look at A. Left-hand side unit is T. T is a period, so the unit of T is second. Second, For A, I'm going to do it here. Second is equal to 2 pi. 2 is a number. Pi is a constant without the unit, so we just ignore. Now, the problem is the K, spring constant. But worry not. Do you still remember Hooke's law? Hooke's law? Hooke's law states that F equals Kx. All we need to do is just to make sure that the force must be placed in terms of the base units. So force, I try to split it into simpler form. So F is equal to MA equals Kx. M is the mass, the unit of mass is kilogram. Acceleration is ms -2 equals K. X is the extension, though, so the SI base unit of extension is meter. And after that, just make K as the subject. So kilogram meter per second square divided by meter. So you can cancel off the meter, you get kilogram per second square. That is the unit of K. Now all I need to do is just to sub into the right-hand side equation. So like what I say, 2 pi, yeah, 2 is a number, pi is a constant without a unit, you just ignore them. K is a constant with the unit, it is kilogram per second square, divided by the mass, which is kilogram. Cancel and cancel. On the right-hand side, you get S -2. So left-hand side base unit is not equal to right-hand side unit. A cannot be your answer. Oh, what about B? Let me change the color of the pen. For B, the left-hand side unit is still second, so we don't have to worry about that. But the right-hand side unit, 2 pi, just ignore. Right-hand side unit, mass is kilogram, and K is kilogram per second square. I just cancel it off. I get second to the power of 2. So they are not equal. B cannot be the answer as well. What about C? Left-hand side unit is S, second, and the right-hand side. Okay, so I have to do it. Kilogram per second square, that's the unit of K, divided by kilogram, and I have to square root the whole thing. So kilogram and kilogram I just cancel. Square root of S to the power of -2, I get S to the power of -1. It is still not the same, right? The left-hand side base unit is still not the same as the right-hand side base unit. So C cannot be the answer. And you're supposed to know that D is supposed to be the answer, but I'll just confirm that D is the answer. Let me prove it. Left-hand side unit is second. Right-hand side unit is kilogram, that's the mass, per kilogram per second square, square root. And kilogram cancel. S to the power of -2, you just move up, become S to the power of 2 or S squared, square root it, you get S. So left-hand side unit equals right-hand side unit. D is your answer. Now, question number 4. An object is of fixed mass is initially at rest. I love to write this, U equal to 0, when the mass is fixed at rest at point P. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? Remember, this object is supposed to be at rest initially. Those are the hints. And after that, the object is moving away. That is also meaning to say that with uniform acceleration. So the object will move away with constant increasing speed. That will give you uniform acceleration. Remember the equation that I used just now, F equals ma. M is constant. Why? Because the mass of the same object is always constant. So the force is directly proportional to A. Since the acceleration is uniform, the force must be constant. Uniform means constant or uniform. So let us read the choices given here. A, it increases uniformly. How can you increase uniformly when the acceleration is not increasing? This is wrong. B, it is constant. Constant is the correct word to be used, but not zero. Yes, it is true because acceleration is not zero. C, it is proportional to the displacement from point P. This is not true, and it is zero. That is not true at all. When there's acceleration, there must be resultant force. The answer is B. Question number 5. A projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of velocity of 13 meters per second. What is the vertical component of the velocity of the projectile when it is launched? First of all, when this is about projectile, I would strongly suggest you to draw out the whole diagram. So this is a diagram. See, 25-degree, and the velocity, horizontal velocity is 13. It is not the resultant velocity to be 13 meter per second. So you have to beware with that. So whenever you label everything, this is right angle triangle. So I'm going to use the Pythagorean theorem to find my answer. I use tangent, opposite over adjacent, and I make V in Y direction as the subject. So V in Y direction is 13, tangent 25-degree. So my answer is 6.06 meter per second, or B is the answer. Question number 6. A ball is released from rest at position X at time 0. It bounces at 1 second. It bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. What is the total displacement of the ball from its original position X at 1.5 seconds? Now look at the graph given. This is a velocity against time graph. How do we find displacement? Simple. So when a graph is given, there are two information that you could obtain from the graph. One is the gradient of the graph. The gradient of velocity time graph represents acceleration. And the other one is the area under the graph. The area under the graph represents displacement. So since they asked me to find the total displacement, I have one positive displacement and the other one is negative displacement. Remember, displacement is a vector quantity. So you have to consider the positive direction as well as the negative direction. So I'm going to do it one by one to avoid careless mistake. I'm going to find the area for this triangle first. So the area of this triangle, because displacement represents the area under the graph. So this is the area of triangles. Therefore, I get half times 1 times 10, and I get 5 meter as my answer. And after that, I'm going to find the displacement of the small little right angled triangle. So how am I going to do it is that, okay, so remember, negative must be taken into account when you do this. Negative 5, 1.5. Okay, the length here is 1.5 minus 5, which is 0.5. Don't make careless mistake. So you will end up getting negative 1.25 meter. Look at the question again. The question asked me to find total displacement. So total is the sum of all the displacements here. Sum total displacement, that gives you 5 meter plus negative 1.25 meter, and you end up getting 3.75 meter, which is B. So B is the answer. Now, the next one, number 7, what is the definition of acceleration? Remember one thing, there is only one definition for all the physical quantity. Acceleration is defined as the change in velocity per time taken. Change in velocity per unit time. That is the definition of acceleration. So A is the answer. Now, question number 8. Two balls, P and Q, of equal mass move along a straight line directly towards each other as shown. Ball P has a velocity 1.3 meter per second to the right. Ball Q has a velocity 0.5 meter per second to the left. P and Q collide with one another, and the collision is perfectly elastic, and the total momentum is conserved, which diagram correctly shows the motion of P and Q after the collision. Now, I want you to see this. Very simple, perfectly elastic. What does the question mean by perfectly elastic collision? It meant that it perfectly elastic collision means that the total momentum before the collision must be equal to the total momentum after the collision, as well as the total kinetic energy before the collision must be equal to the total kinetic energy after the collision. If you want to try the long way, you're supposed to use momentum, total momentum of P and Q first. You add them up, equals, you have to do it one by one for all the choices here. And to find the momentum after, which is equal to the magnitude of the momentum before the collision. And then after that, you're supposed to prove the second thing, which is the total kinetic energy of P and Q before the collision must be equal to total kinetic energy of P and Q after the collision. But I'm not going through all these troubles, and it is time consuming. Remember, this question is it is coming out in paper one, so we don't have to prove a lot of things. We don't have to do a lot of calculation. I want to teach you the shortcut, the easier way to do it. After all, you don't have a lot of time to be wasted, remember? So what should you do when you see this type of question? First of all, you need to search for the keyword. The keyword is perfectly elastic. So when the collision is perfectly elastic, we can also say that the relative speed of approaching of P and Q must be equal to the relative speed of separation of P and Q. So how do you calculate the relative speed of approaching? Remember, relative speed of approaching, relative speed of separation, they have nothing to do with the masses of P and Q. It doesn't matter whether P has a larger mass or Q has a smaller mass. It doesn't matter at all. So all you need to do, the shortcut is that you look at the direction of the velocities of P and Q. See this? If P and Q are moving in the opposite direction, when they are moving in the opposite direction, to find the relative speed of approaching, you just add up the two speed. So it is 1.3 plus 0.5. You get 1.8 meter per second. All you need to do now is to check A, B, C, D. Which one give you 1.8 meter per second? So let us look at A first. Look at A. When the two speed or the direction of P and Q, right? The velocity of P and Q are in the same direction, all you need to do is to find the difference. You just need to take 0.58 minus 0.22. I'm going to use my calculator. Give me a while. The 0.58 minus 0.22, I will get 0.36 as my relative speed of separation. So A cannot be the answer because I want 1.8. What about B? B, P and Q seems to be sticking together and move together, yeah, with the same speed. So this is not perfectly elastic. If perfectly elastic, they wouldn't be in physical contact with each other and moving in the same speed. And what about C here? Oh, they are moving in the opposite direction. Look at their velocity. Occur in opposite direction. So what happened? If opposite direction, you just need to add. So 0.19 plus 0.99. That gives you 0.19 plus 0.99. That gives you 1.18 meter per second. But I want 1.8, not 1.18. What about D? Oh, they are moving in opposite direction as well. Opposite direction, 0.5 and 1.3. All I need to do is just to add them up. 0.5 plus 1.3, that will give me exactly 1.8 meter per second. D is the answer. Now the next one. A basketball player hits the ball vertically downwards with a speed of 2.4 meter per second from a height of 0.9 meter. Air resistance is negligible. Why don't you show the solution first before... Okay, never mind. This is just, what is the speed of the ball as it hits the ground? So in this case, I'm using one of the kinematics equations since this ball is being thrown vertically downwards, right? Hits the ball vertically downwards. Yeah, going downwards, up or down. When you talk about the ball is moving in direction up or down, the A, you have to change it to gravitational acceleration of 9.81. So when you sub in all the information here, you should be getting 4.84 meter per second. Meter per second. B is the answer. Question number 10. A ball falls through a liquid at constant speed. It is acted upon by three forces: an upthrust, a drag force, and weight. And this liquid has a uniform density. So uniform density, which one is related to density? Which statement is correct? Now, I am talking about the ball. This is a ball. So there are three forces that are acting on the ball. One is the weight of the ball. And the other one is upthrust force. Upthrust force is a floating force. The other one is a drag force. Drag force is like air resistance. It is the opposing force. It is a force that acting on the moving object. So which is correct? Oh, since the liquid has a uniform density, look at upthrust. Upthrust force. The equation of the upthrust force is rho Vg. Uniform density, that means the upthrust force is uniform because it is still the same ball, so the volume of the ball is constant. So let us look at A. The drag force increases with increasing depth. No, it is related to the speed of the ball. B, the drag force is equal to the sum of upthrust and weight. No, the weight is equal to the upthrust plus the drag force. This is also wrong. C, the upthrust is constant with increasing depth, which is true because the density is constant. D, the weight is greater than the sum of drag force and the upthrust. That is not true because when when the weight is greater than drag force plus upthrust, the ball would never ever falls at constant speed. There will be a resultant force acting on the ball. C is the answer. Question number 11. Some small solid cubes each have mass 1 kilogram and sides of length 5 cm. These small cubes are stacked together to form a large solid cube with side of length 2 meter. What is the weight of large cube? So I have a small little cube. This is a cube. So you remember cube is about 3D. So that is why I cube it because one length is 0.5, 0.5, and 0.5. That is why you have to find the volume of a cube because they are talking about cube after all. It is not a square. That is why I cube it. It's equal to 1 kilogram. So you want to form a large cube, which is 2 meter, 2 cube. You get 64,000 kilogram. Just use W equals to mg because it is mass times gravitational acceleration. So the mass of the large cube will be 64,000 times 9.81, which is 0.63 times 10 to the power of 6 Newton. Or 10 to the power of 6 represents mega. C is the answer. Number 12, a borehole of depth 2000 meter contains both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascal. Density of the oil is 830 kilogram per meter cube and the density of the water is 1000 kilogram meter per meter cube. What is the depth X of the oil? First of all, this is not the first time this question is being asked. It is a repeated past year question. So how you are going to solve this kind of question? First, all you need to do is just to write down all the informations given. What is the depth X of the oil? They gave you the information given here is the total pressure, right? Total pressure is given as 17.5 times 10 to the power of 6 Pascal. Mega represents 10 to the power of 6. And how do you find, since the density of the water is being given, how do we find the pressure of the water? Pressure of the oil will be density of the oil times G times height of the oil occupied. So height of the oil occupied will be X. Then pressure of the water would be density of the water, which is given, times G times height of the water. So to find, this is what I call height of the water. To find height of the water, it is the total height, 2000 minus X. So write down the equation. Total pressure is due to the pressure of the oil plus pressure of the water. So equation of pressure of the oil is rho GH. So density of the oil is 830. G is 9.81 and the height of the oil is X plus density of the water is 1000 and G is 9.81. Height of the water is 2000 minus 8, which is equal to the total pressure. All you need to do is just to solve it. Eventually, X that you need to get is 1271 meter and I round it off to D. Now, question number 13. A rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0 degrees. The weight of the rod causes a moment m about the pivot. The rod is then rotated in the vertical plane so that the angle theta of the rod increases from 0 degrees to 180 degrees. which graph shows the variation m with theta? It seems a little bit of complicated here. I drew up the diagram so that it's easier for me to see. So when the rod is horizontal initially, and all you need to do, rotate vertical from 0 degrees to 180 degrees, opposite. Yeah, vertically, right? So you rotate in vertical plane, y-axis, vertical plane means downwards or upwards. So I move the rod downwards, and that's my theta. So if I want to redraw that out, this is horizontal distance, this is theta, and this is the length of the rod. So to find the what are we are, this is pivot. So to find the moment, remember the force, and this is a force because you keep on pushing the rod downward. So this is the direction of the force, and pivot is here. Since the force is acting in vertical direction, you have no choice but to find the distance of the rod or the length of the rod in terms of horizontal direction, because moment after all is equal to force multiplies by perpendicular distance. Since the force is acting in vertical, the distance must be horizontal to form perpendicular distance. So I resolve this. This is my cos theta adjacent d horizontal divided by d. Therefore, my d horizontal, distance horizontal, is equal to d cos theta. My moment will be W, which is the weight of the rod, times d cos theta. So the graph, the important thing is you look at this one, cos theta. So the graph of cos graph is like this. So you start with a certain maximum value first. A cannot be the answer because this is not a cos graph. D, it seems like it rebounds back. So this is not the answer as well. What about C? Is this not a straight line? D is the answer. Now the next one, a hinge trapdoor is held closed in a horizontal position by a cable. Three forces act on the trapdoor: the weight W of the door, the tension T in the cable, and the force H at the hinge. Which list gives the three forces in increasing order of magnitude? When I see the diagram like this, it kind of make me confused. So just to make sure that things go smoothly, I redraw. Since all this, there are only three forces, so I could form a closed triangle with the directions labeled there. And to find the increasing magnitude, I am actually using a little bit of math. So I want you to look at T here, the theta of T, okay? I don't know whether you learn at math, or one of the at math equation is A over sine A. I look at T here. Okay, the theta of T is the largest one. So I would say that T is the largest one. And the theta, you just, if you want to find the theta of T, T must be looked, okay, opposite to the theta. And this is the theta of W, and this is the theta of H. Theta of H seems to be larger as compared to theta of W. So the smallest magnitude, the force that is the smallest one, would be W, followed by H, followed by T. C is the answer. Number 16, what's the definition of force? Remember what I told you in the earlier slide? There's only one definition for all the physical quantity. So let us look at A. The product of mass and acceleration seems to be correct, but I'm sorry, this is not the definition of force. The product of mass and velocity, this is the definition of momentum. The rate of change of momentum seems to be correct. I will explain more. The rate of transfer of energy, this is not true. The rate of transfer of energy over time, that is power. So why C is the answer? First of all, recall Newton's second law. Newton's second law states that the resultant force is directly proportional to the rate of change of momentum. So F is equal to mv minus mu over t. Okay, K with the K value 1. F is equal to factorize out the m, v minus u over t, v minus u over t, that's the definition of acceleration. So F equal to ma. F equal to ma is actually modification from Newton's second law or from the definition of force to simplify our calculation. So definition of force, C is the answer. Number 16. A boat moves at a constant velocity v through still water. Water is not moving. A constant drag force F acts on the boat. What is the power used by the boat to move through the water? If you see that the boat is moving with constant velocity, power is always equal to F. This equation of power is only valid when object is moving with constant velocity. B is the answer. Number 17, the diagram shows four forces acting on a circular disc. Each force has magnitude F. Two of the forces act vertically and the other two forces act horizontally. All four forces act in the same plane as the disc. No other forces act on the disc. The disc has a diameter of d. So let me write it down, d. Which statement is correct? I want to see whether the whole system or the disc is in equilibrium or not. Okay, when I see that I have to detect couple. Do you know what is couple? Couple means that there are two forces that are acting in opposite direction. They have the same magnitude and they are being separated by a distance. I can see that this F, vertical upwards and vertical downwards, these two form a couple. And the other two forces, which are this one and this one, form another couple. So when you detect couple, bear in mind, couple can never ever produce equilibrium. Couple will produce pure turning effect. So I will have to cancel A and C because they are not the answer. Let us look at B. The disc is not in equilibrium because the resultant force. How to find the resultant force? That also, resultant force is the addition of all the forces that are acting on the same object. So upward force is balanced by the downward force, vertical. Vertical resultant force is equal to 0. What about horizontal force? Left-hand force is balanced by the right-hand force. The resultant force is actually 0, so B cannot be the answer. What about D? The disc is not equilibrium because the resultant torque is 2Fd, which is true, right? Because this moment produced by this couple, how to find the moment produced by the couple? First, you just take the magnitude of one of the two forces times the perpendicular distance between the two forces, Fd. The other moment, okay, produced by this couple will be Fd as well. So Fd plus Fd, you get 2Fd. D is the answer. Now, question number 18, a ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energies EQ, ER, ES, and ET, respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. Thank goodness. Which difference in kinetic energies is the smallest? Do you know how I solved this question? Since the heights are being given, so I'm actually find the difference in height because air resistance is negligible. So I would say that the change in gravitational potential energy is equal to the change in kinetic energy. If I want to get the smallest change or the smallest difference in kinetic energies, I just find the smallest change in height. I'm using this. GPE is equal to KE. Now, or the change in GPE is equal to the change in KE. Let us look at the first one, EQ, ES. EQ and ES, okay, it is the height difference, delta H is equal to 1.6 meter minus 1.5 meter. I get 0.1 meter. What about B, ES and ER? The change in height ES and ER, 1.8 meter minus 1.6 meter. So the change in height is 0.2 meter. What about C, ET and EQ? EQ. So the change in height, you just take the larger number, 1.5 meter minus 1.3 meter, you get 0.2 meter. What about D, ET, ER? Where is ET and ER? Oh, ET is 1.3, ER is 1.8. 1.8 meter minus 1.3 meter. 8 minus 3, that's 0.5 meter. That's a big difference. So you find the smallest difference in height, that will be the answer. My answer is 8. The next one, the battery of a small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours to charge the battery. The efficiency of the charge process is 80%. What is the total energy stored in the battery? So how do you find efficiency? There are three equations of efficiency. One is the useful output power over input power times 100%. Or if you don't like this, you can use useful output, change this to energy, useful output energy over input energy times 100%. Or if you don't like this equation, it doesn't matter, useful output work divided by input work times 100%. That could be the equation of efficiency. I am using energy. So I need to find the energy supply because they asked me the total energy store. So I resolve it in terms of energy, which is equal to power multiplied by time. So this is the energy supply by the battery, by the power supply to the battery. So the power supply is 10 watt and the time taken is 2 hours. You have to convert to second because energy must be measured in joules. So 2 hours, change it to minutes times 60, change it to second times another 60. So the answer is 72,000 joules. That's the energy supplied by the power supply. And efficiency given here is energy stored divided by the energy supply. So I need to find the energy stored in the battery. Efficiency is 80%, so 80 divided by 100. So all you need to do is just to sub in into the equation, do your cross multiplication. The energy stored in the battery is 5.76 times 10 to the power 4 joules. So C is the answer. Number 20, an initially stationary firework explodes and splits into two fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. One fragment has mass m and the other one has mass 2m. What is the speed of the fragment of mass m immediately after the explosion? So how you're going to do about this is that you look in terms of kinetic energy. And since this obey this kind of situation, you can use explosion obeys the principle of conservation of momentum. So you can use the principle of conservation of momentum to solve this as well. So I'm going to draw out the whole diagram here. Fireworks, because it is stationary, so no point for me to draw it out. So after the explosion, split into two fragments moving horizontally in opposite directions. M is moving, I would just say M is moving with V1 and 2M is moving with the speed or velocity V2 in the opposite direction. And since the principle of conservation of momentum is obeyed, 0 is equal to negative m v1 plus 2m v2. So I modified m1 v1 is equal to 2m v2. So I make v2 as the subject because I want to find V1. So, and then the total kinetic energy is given. So I'll say kinetic energy of V1 plus kinetic energy of 2m, kinetic energy of m plus kinetic energy of 2m is equal to E. And I sub V2 as V1 over 2 into the equation. So eventually when I work out the equation, I get 4E, square root of 4E over 3m. D is the answer. Number 21, a spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. Which relationship is correct for this spring? So use the Hooke's law equation. Total elastic potential energy is equal to half kx squared. K is a constant because you are using the same spring, a spring. So elastic potential energy is directly proportional to x squared, extension squared. D is the answer. Number 22, a force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? So let us look at A. Limit of proportionality is the last point where Hooke's law is being obeyed. So let us look at A, the point at which the wire breaks. That is what we call elastic limit. B, the point beyond which Hooke's law is not obeyed. It seems true. D, the point beyond which wire cannot return to its original length. That is what we call yield point. D, the point beyond which wire starts to deform elastically. This is also yield point. Therefore, the answer is B. The next one, question number 23. A spring has a spring constant of 6 Newton per cm. It is joined together to another spring whose spring constant is 4 Newton per cm. A load of 80 Newton is suspended from this composite spring. What is the extension of this composite spring? First of all, when you see these two springs are being connected in series, all you need to do is just to find the total spring constant. For springs being connected in series, the spring constant is 1 over 6 plus 1 over 4 and 1 divided by the total answer. So the total spring constant is 2.4 Newton per meter. And after that, just apply Hooke's law, F equals to Kx. F is equal to 80 Newton because the load is 80 Newton. K is the total spring constant, 2.4. And X is just the extension. So the extension is 33.3 cm. You have to change it to, this one is Newton per cm. Yeah. So it is 2.4 Newton per cm. It's not Newton per meter because this is Newton per cm, Newton per cm. So I don't have to convert to meter. Yeah? So D is the answer. Question number 24. The range of frequencies of sound wave emitted by blue whales is 10 hertz to 40 hertz. The speed of sound in seawater is approximately 1.5 kilometer per second. What is the approximate range of wavelengths of the sound waves emitted by blue whales? If you want to find the range, you need to get the smallest value and the largest value. First, I am using the equation of V is equal to F lambda. So you remember this is equation of wave. Lambda is equal to V over F. So to get the minimum lambda, I have to use the maximum frequency. And why do I take 1.5 times 10 to the power of 3 for the speed of the sound? Because this is kilometer. I have to change it to meter. So divided by 40, I get 37.5, or you can round it off to 38 meter. And lambda maximum is 1.5 times 10 to the power of 3 divided by frequency minimum, which is 10 hertz. You get 150 meters. So the answer is D. Number 25, a sound wave is detected by a microphone and displayed on the screen of the cathode ray oscilloscope or CRO. The frequency of the wave is 2.5 kilohertz. What is the setting of the time base of the CRO? First of all, you need to draw equilibrium position. Equilibrium position is very important. After that, frequency. So how do you find frequency? Is that, okay, let me give you the equation of time base first. It is not the equation of time base, actually, it is the equation of period. So from CRO, if you want to find a period, first of all, you need to take the number of cm involved for one complete oscillation. This is what I call one complete oscillation. Here. This is called one complete oscillation. So how many cm involved here? I have 1 cm, 2 cm, 3 cm, and 4 cm. So 4 cm times the time base to get period. Since frequency is being given, how do we find period from frequency? Period is equal to 1 over frequency. So period is equal to 1 over 2.5 kilo is 10 to the power of 3. So period is equal to 1 divided 2.5 times 10 to the power of 3. The period should be 4 times 10 to the power negative 4 second. So 4 times 10 to the power negative 4 second is equal to 4 cm times time base. I put TB as time base. So the time base would be 0.1 millisecond per cm. So A is the answer. Number 26. A source of sound wave with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at observer's position with the waves emitted by the source of the sound. What is detected by observer? So the sound wave constant frequency move toward, um, let me see, if it is moving towards the observer, the observe frequency is supposed to increase. So there is no decrease, no change. This is not the answer as well. A decrease in the wavelength, frequency and the wavelength. I am using V equal to F lambda, the equation of the wave. Frequency, since the speed of the wave is constant, right? Because that is the speed of the sound. F is inversely proportional to lambda. I want my observed frequency to increase, so my observed wavelength must decrease. C is the answer. Number 27, which type of waves cannot be polarized? Only one wave cannot be polarized, which is longitudinal wave. There is only one example of longitudinal wave, which is sound wave. Number 28, a beam of light with power P has an area of cross-section A. Amplitude of the light waves in the beam is X. The beam of light is then changed to one with the same frequency, but with an increased amplitude of 4X and an area of cross-section reduced to A over 3. What is the power of the new beam? First of all, find out the relationship between intensity and amplitude, or cross-section A and power. So intensity is defined as power per unit surface area. And intensity could also be related to amplitude, because intensity is directly proportional to amplitude square. So I would say that Kx, in this case, I'm using X, amplitude is given as X. Kx square is equal to power over surface area. So that is my first equation. Now the beam of light is changed. The amplitude increased to 4x, so you have to square it. P, you have to find a new power, because since the amplitude is changing and the cross-section is changing, the power will be changed as well. So A over 3. So use these two simultaneous equations to solve for the new power, which is 5.33p. B is the answer. Number 29, the loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. The loudspeakers face each other so that the stationary wave is set out in the region between the loudspeakers. The microphone is connected to a CRO and positioned between two loudspeakers. The microphone is moved along the line joining the two loudspeakers. The signal on the CRO shows 5 maximum amplitudes that is subjected to NT notes. As the microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives the 5th maximum. What is the wavelength of the sound wave? For the question like this, you cannot just use your brain to do it. I would strongly suggest you to draw a diagram like this. So I'm going to draw a diagram here and solve it for you. So the diagram is, first, you draw a horizontal position. After that, I draw my stationary wave. So it is up to you. How many? Okay, stationary wave. Okay, just draw your stationary wave. Okay, so I'm using different color to show that one is wave from one loudspeaker and green wave is from the second loudspeaker. And the question did mention that microphone is moved the distance 2 meters from the first maximum to the 5th maximum. So from the first maximum is from here. So you have to cut from here. First maximum, second maximum, third maximum, fourth maximum, and the 5th maximum. So it is just this area that we need. I am going to highlight it. Only this part that we need. Everything here. Okay. Bear in mind, one loop represents 1 over 2 lambda. This is 1 quarter of the loop. So this is 1 over 4 lambda. This is 1 over 2 lambda. 1 over 2 lambda, 1 over 2 lambda, and 1 over 4 lambda. Add them out together. That will give you 2 meters. So it is 4 over 2 lambda that gives you 2 meters. Lambda is equal to 1 meter. So the answer for this one is D. So question number 30, let me erase that first. Question number 30, two wave sources emit coherent wave. Which condition must be correct for coherent wave? Must be correct. That also means that the waves must be emitted with a constant phase difference, which is V. 31, a student set out an experiment to investigate double slit interference. The student uses the light of a single wavelength from a laser to illuminate a double slit so that a pattern of interference fringes is observed on the screen. Student finds that the fringes are very close to each other. What could the student decrease in order to increase the separation of fringes on the screen? First of all, recall the equation of the interference. You get lambda equals AX over D. What does this lambda represent? Lambda represents the wavelength. A represents the slit separation. X represents the fringes separation. And D represents the distance from slits, double slits to screen. That is D. Now, they ask to increase the separation of the fringes. So you make the separation of the fringes as a subject. So X equal to lambda D over A. If I want to increase the fringes separation, I have to increase the wavelength. I have to increase Q in this case. I have to decrease R in this case. The answer is I want to decrease. The only thing to decrease is R. C is the answer. Now the next one, question number 32. What are the definition of potential difference and electromotive force, EMF, in terms of energy transfer and the charge Q? Potential difference is defined as work done in moving a charge from one point to another point, W over D. Whereas the electromotive force is defined as work done by the supply of the source, or energy supplied by the source, or work done by the source in moving a charge through a complete circuit over Q, because it is still the work done. Yeah, so A is the answer. Now, question number 33, the diagram shows a network consisting of three resistors. What is the combined resistance of the network between terminal X and terminal Y? So could you see that this is a little bit of complicated? Why don't we make this circuit to simplify the circuit a little bit? Could you see that 1.2 kilo ohm and 4.7 kilo ohm are connected in parallel? So I try to modify the circuit to be a simpler one. So solve for parallel circuit first. R total for parallel is 1 over 2 kilo ohm plus 1 over 4.7 kilo ohm, and invert that. So you get 0.9559 kilo ohm. So this is a simplified circuit. And all you need to do, because 2.2 kilo ohm and 0.9559 kilo ohm are being connected in series, therefore, solve for series. The R total will be just addition of these two, which is 3.16 kilo ohm, or you round it off to 3.2 kilo ohm. That's the answer. Number 34, a resistor dissipates 25 watt of power, and when there is a potential difference PD of 4 volt across it, what is the resistance of the resistor? So how do you do? I am using the equation, one of the equation of power. Power is equal to V square over R. V square is given, which is 4. You just square it. Power is given, which is 25. All you need to do is just to rearrange, make R as a subject. You should get 0.64 ohm. B is the answer. Question number 35. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. Resistance of the variable resistor is decreased. Resistance decreases. What happens to the potential difference V across the variable resistor and the current I in the variable resistor? So you know that resistance and current, they are opposite of each other. So if the resistance is being decreased, the current must increase. But for the potential difference and the resistance, they are directly proportional to each other. So when the resistance decreases, the V will have to decrease as well. B is the answer. Now, question number 36. A radioactive source produces a beam of alpha particles in a vacuum. The average current caused by the alpha particles in the beam is 1.5 times 10 to the power negative 9 ampere. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in a time of 3 seconds? So how do you do about this? First, alpha particle, you have to bear in mind alpha particle is a helium nucleus. I am using Q equal to IT, Q it to find my charge. And the charge can also be equal to the number of the electrons that flow times the charge of one electron. So I talk about charge. Electron is the basic of charge. So if alpha particles, it involves 2 times the charge of the electrons because the charge of alpha is 2e. So I put Ne, N represents the number of alpha particles times the charge of alpha particles is equal to IT. So E is 1.6 times 10 to the power negative 19. And I is given, which is 1.5 times 10 to the power negative 9 ampere. And T is given in 3 seconds, so you don't have to change anything. So make N as a subject, you should get 1.41 times 10 to the power of 10. C is the answer. Question number 37, the charge carriers in a metal wire are free electrons, which is true. Which statement about the charge of each free electron is correct? Let us look at the answer one by one. A, the magnitude of the charge increases with potential difference across the wire. Magnitude of the charge increases? No, it would not increase. B, the magnitude of the charge is 0 unless there is a potential difference across the wire. The magnitude of the charge is always 1.6 times 10 to the power negative 19, whether there's a potential difference or no potential difference across the wire. C, the sign and magnitude of the charge do not depend on the potential difference across the wire. Of course, the sign of the charge, because if depending on the potential difference, electron will flow out from a negative or negative terminal, right, to the positive terminal. So of course, it would depend on the potential difference across the wire. So this is wrong. D, the sign of charge depends on the potential difference across the wire. Yes, because it depends how you arrange that battery or the cell, because the electron will also only flow out from negative terminal to positive terminal. Now, question number 38, which flavors of quark have a charge? This is about memorization. So charge positive 2 over 3e, that is charm and top. A is the answer. Now, question number 39, an unstable nucleus of an element decays by emitting an alpha particle or a beta negative particle to become a nucleus of a different element. Nucleus is also unstable and emits an alpha particle or a beta negative particle. The process continues until an isotope of the original element is produced. What is the minimum possible number of these particles emitted? Okay, I want you to see this. Keyword is this. Isotope. So for isotope, you have to bear in mind proton number will be the same. Let's say, okay, this nucleus emit 1 alpha because they say that this nucleus must emit alpha and beta. So I would just say that it emits 1 alpha first because I want to find the minimum possible numbers. Right? If emit, this is the nuclide notation for this unstable nucleus. A represents a nucleon number, Z represents a proton number. Remember, isotope, I need to get back the same proton number. So emit, that means you have to minus. And then minus beta as well, because this unstable nucleus emit both particles. So minus n number of beta, because I want to find what is the number of beta if 1 alpha is being emitted. So you look at the final nuclear number, A minus 4 minus 0, because the nuclear number of beta negative particle is 0. And proton number is the main thing. Z minus 2 minus and negative becomes positive. So I want to get back Z as my final answer because after all, it will produce the isotope. So I will say Z minus 2 plus N is equal to Z. So N is equal to Z minus Z plus 2. So N must be 2. So at least 2 beta negative particles must be emitted with every 1 alpha particle. Therefore, the total minimum possible number, I get 1 alpha, but I need to have 2 beta. So altogether must be 3 particles. Now, question number 40, last question. A nucleus of carbon 10C decays by beta emission to form a nucleus of boron 10B. For this decay process, what is the change to a nucleon, and what is the charge in the quark composition of the nucleon? Okay, write down the equation 10C to change to 10B. Look at the proton number from 6 decreases to 5. So 1 positron must be emitted. So recall positron. This is the decaying of either proton or neutron. In order for the positron to be emitted, proton must be decayed. So the decaying of proton gives rise to neutron plus positron and neutrino, the energy. So the change to nucleon is from proton to nucleon. And the change in quark composition, proton has up, down quark, neutron has down, quark. So 1 up quark changed to down quark. Up becomes down, so B is the answer. So that's the end of the discussion. I hope you find benefits in this discussion. Okay, bear in mind, your A star depends on your determination and hard work. Good luck to all the students. Let's see you in my next video. Bye.